2,4a. And we're going to talk about rates of change. So there's really two types of rates of change. There's an average change, and then there's an exact instantaneous change. So if you think about, for example, let's say a rocket ship going off and then coming back down and hitting Earth or something, you can think about, like, from 0 seconds to 3 seconds what the average rate of change is. And that's just the slope of the line from 0 to 3. But if I ask you how fast or what was the speed of the rocket at exactly 3 seconds, you can't find the slope of that, technically, because in the old school way, because you don't have 2 points, you have 1 point. So in physics, do you do that in physics? You find the instantaneous velocity of something?
Yes.
Yeah, well, that's what we're going to do today, too. All right, so here we go. First part. All right. The first thing we're going to do is we're going to talk about the average rate of change. Average rate of change is an Algebra 1 topic. So you're going to get this okay. Average rate of change. Here we go. The average rate of change is just basically, it's the slope of the line. Okay? Slope of the line. It's the amount of change divided by the time. Okay? And we usually know it as, you know, our slope formula. M equals, hopefully you still know the slope formula, y2 minus y1 over x2 minus x1. So let's do a problem here. Now, you know, slopes of lines are always constant. If I graph the line y equals 2x plus 1, its slope is 2. Its rate of change is 2, rise over run, right? But something like this, number 1. If I want to find the average rate of change of something that has a curve to it, okay, of something like this, f of x equals x cubed minus x. Find the average rate of change over the interval from 1 to 3. Okay? So for this graph, if you were to go ahead and graph this thing, you can graph it on the calculator. If you're going to graph this, it would, here's 1, and here's 3. And then what this graph does is it goes through -1, through 0, up through 1, and it goes like that. It doesn't go like as a line. I should draw that a little bit better. Let me start over. All right, it goes through -1, it goes through 0, and it goes, that's still sucky. Oh well. Okay, it looks something like that. Yeah, but it's curving, it's not a line. Okay, I drew it a little straight, but you get the idea. So right here, we want to find the average rate of change from 1 to 3, okay? So we're going to find the slope of the line that contains those 2 points. And what it really looks like, a better drawing, is if you have 1 and then you have 3. Oh, that's not 3, that's 4. 3 is right here. At 1, you get 0. And at 3, what does 3 equal? What's the y value of 3? What's f of 3? It's 3 cubed, which is what? 27 minus 3, so you get 24. Okay, so it's a curved line like this, and we're trying to find the slope of this line right here. That's a better idea of what's happening, okay? So we're finding the average rate of change. So all you do is you find the slope between those 2 points. So one of my points is the point 1, 0, and the other point is 3, 24. Okay, pretty easy, right? So you'll do 24 minus 0 over 3 minus 1, 12. So the average rate of change is 12. And we're not doing any type of units right now, but it's a pretty steep slope. Okay? It's going from 0 all the way up to 24 in 2 increments, so it's pretty good. Now, let me show you how that would work in an everyday today problem. Let's say that you are working in a lab and you're studying fruit flies. Sounds like a dream job. Oh, your weekend job. Oh, okay. Or just weekend hobby.
Just for fun.
Oh, for fun. All right, fruit flies. Now, on day 23, you observe that the fruit fly population is 150 flies. Gross. On day 45, you observe that there has been an increase in the population of fruit flies to 340 flies now. Now, this is a word problem, and so your answer is going to involve words too. Okay? We're going to find the average rate of change in the fruit flies per day. Average rate of change. Okay, average is just, it's an average. Like that quiz I just gave back to you. The average was a B. There were not B's, and there were A's, and there were...
How was the average a B?
Because some people got a 26 out of 25, one person. Some people got a 25 out of 25. A lot of people were in the 24 range. Raise your hand if you got an A on that quiz. Okay, so an average rate of change is not the exact rate of change. Maybe on day 30 there is a burst of population, or maybe on day 31 there wasn't that much. But the average between all the days is just to find the slope. So we're going to find flies per day. So here we go. We're going to do 340 minus 150 over 45 minus 23. And then you get your calculator out, and it ends up being approximately 8.6 flies per day. Okay, so it's just an average. Now, what happens when we want to find out how many flies actually increased on day 42? Okay, that's instantaneous rate of change. That we're going to need a limit to find that. Okay, so let me talk to you, part B, about some calculus now. So we're done with our algebra portion of the day. Now we're going to get to calculus. So here we go. We're going to talk about a tangent line. Tangent line. Now, do you know teachers who lecture and they go off on a tangent?
Yeah, that's you.
Yes, me, of course.
There's good tangents.
Yes, they're good tangents sometimes. So let's say you're walking along with your friend, and you're talking, and all of a sudden your friend goes off on a tangent, right? Goes somewhere else. Okay, that's the same idea of what we're going to do. It's a tangent line. It's going to go right next to where we're going, and it's going to show you what the slope is at that point. So if you have, for example, pretty sweet curve right here. There it is. Okay? And this is a nice good old polynomial. Looks like a cubic function probably. And if I wanted to find the rate of change at exactly one point, like say that point right there, I know that that has a positive rate of change, right? It's going up. So I would need to find the slope of the tangent line. Now you physics nerds out there, what's the rate of change at this point?
0.
0. Yeah, because the tangent line has a slope of 0 there. See this green point right here? That green point? The average rate of, or the exact rate of change on that point would be a negative slope because it's going down. Okay? So this is what we're going to do. We're going to find the slopes at all these places, but we can't really do it using our old slope way because we don't have 2 points to use. We only have 1. So here's how we derive it. Are you ready? This is the most exciting thing so far this school year. You're going to miss it by talking. Okay, here we go. Suppose I have some graphs curved, okay? And let's say that I am looking for the rate of change at this point right there, which has a value of x. And so that point is x comma f of x, because this is the graph y equals f of x. Okay, everyone agree with that so far? Doing pretty good. All right, so I can't really find, using the slope formula, I can't find one unless I have another point. So I'm going to put another point on my graph, and I'm going to put it a distance of h away. So this red point has the coordinates what? X plus h, comma, f of x plus h, right? Does that make sense? So I'm at x, I go a distance of h away. Who knows what h is? I don't know. It could be really big, it could be really small. the distance here. And so that makes this point x plus h. And then when you want to find the y value, you plug in x plus h to find the y value. Okay?
You don't change it for the y. Because there's not an h on the y-axis or anything.
No, but if I want to find out what f of 3, if x is 3, and I want to find out the y value, I do f of 3. If f is p, then I would do f of p. So x is x plus h, I do f of x plus h. Thank you. Okay, so now what happens is I get this line, which isn't necessarily that good of an estimate yet. That green line right there that I just drew, the green line is called the secant line. Not to be confused with your trig terms. Secant and tangent I know are trig terms, but they have nothing to do with trig here, okay? Nothing at all. I know they're the same name. I don't know. So the green line is called your secant line. So this is what we're going to do. We're going to take h and we're going to shrink it. We want to shrink that difference between them all the way until it becomes 0. And when that distance between those 2 points is 0, then I can find my tangent line. Okay? Now how do I do that? I take the limit as h goes to 0. All right, so my 2 points on my secant line. Is that you? Oh. My 2 points are x, f of x, and x plus h, f of x plus h. And let's say that I want to find the slope of the secant line. To find the slope of the secant line, I would do y minus y over x minus x, right? y2 minus y1. So f of x plus h minus f of x all over x plus h minus x. Okay, simplify that. So I get f of x plus h minus f of x all over h. And in order to find the tangent line, what we're trying to do is we're trying to get that h to become 0 so that they are the same point. And so we are going to, I drew this equals here, we are going to take the limit as h approaches 0. And there it is. That right there is your formula to find the slope of the tangent at any point. Does anyone remember this from last year?
Yeah, a little bit.
Yeah? Only if you were in ham.
Which semester?
Second semester. You were here for that. It was the end of the year when we did limits. We did the tangent line problem too. Okay? All right, slope of the tangent. This is exciting. Now we're going to do some. Are you ready?
Are you sure?
Yeah. You just got here. Okay, here we go. Number 3. Number 3.
I was talking with the teacher this week.
Okay, here we go.
Oh yeah, me too.
F of x equals x squared. So we have f of x equals x squared, and you know that this is a parabola. And we are going to find the slope of the tangent at the point 3, 9. Okay? We want to find the rate of change that is going exactly at x equals 3. And we have no second point. We're not finding the average slope. So we need to find the slope of the tangent. We're going to have to use our formula. Okay? So here we go. We're going to take the limit as h goes to 0. Now here comes the first part. Now there's 3 parts to this, right? There's f of x plus h minus f of x and an h on the bottom. Okay? So let me show you how you do each of these. First of all, we need to find out what f of x plus h is. Now, our function is x squared. So if I asked you to tell me what f of 5 is, what would you do? You would plug in 5 and you would square it, right? What if I asked you what f of m was? What would you do? You would plug in m and you would square it. So what if I ask you what f of x plus h is? You plug in x plus h and you square it. Okay? So that will go right here. F of x plus h is x plus h squared. That's the hardest part of this whole thing. And then minus f of x. f of x is always going to be the function they give to you, all over h. Okay. Let me go ahead and do a little erasing because I really don't want this here. All right, so now what's going to happen is I need to evaluate this limit. Now, if I plug in 0 right away, I will get 0 over 0. Okay? It doesn't mean that the limit does not exist. It means there's a problem at 0, but the limit still exists. So we're going to have to use some algebra. Here we go. We're going to find the limit as h goes to 0, and we're going to do some algebra work here. So let's FOIL this whole thing out, this x plus h squared. We get x squared. Don't forget the middle term, okay? The middle term is 2xh plus h squared. We FOIL the whole thing out. You're good with that? Okay. Minus x squared all over h. Yeah, now what's going to happen is anything without an h is going to cancel out up top. It always will. If it doesn't, you did something wrong. So those are going to cancel out, leaving us with our terms up top have an h. We're going to factor that h to the front, and that gives us 2x plus h all over h. Is everyone okay with the algebra there? Yeah, you're good at algebra. And then now the h is reduced, getting rid of that problem when I was plugging 0 in. And now I'm going to go ahead and evaluate the limit as h goes to 0 for 2x plus h. So I plug 0 in, and I get 2x. Now, that 2x right there gives me a formula to find the slope at any point. My point in question here is the point 3, 9. So what am I going to plug in for x? 3. Okay? So I go 2 times 3, and the slope would be 6. If I wanted the point 2, 4, I would plug 2 in. If I want the point 5, 25, I plug 5 in. Okay? So that gives you, and think about it. You know this is a parabola, right? Ooh, plug in 0. What's the slope at 0?
0.
It's 0. Okay? When I plugged in 3, 9 way over here, the slope is 6. It's pretty steep. When I plugged in 5, the slope is 10. It's even steeper now. It's getting steeper and steeper. If I plug in -3, my slope would be -6. Okay? Makes sense, huh? Especially for you physics people out there. You've been doing this all along. All right, so now what's going to happen is that's going to be like part A of the question. Part B will be find the equation of the tangent line. Okay? Find the equation of the tangent line. Now, that's not too bad. You have a point and you have a slope. And I would hope by now everyone knows how to find the equation of a line given a point and a slope. What are you going to use? I would choose to use point-slope form, personally. So I'd go y minus 9 equals 6x minus 3. Distribute. They're probably going to want it in slope-intercept form. 6x minus 18, add 9 to the other side. So y equals 6x minus 9. So that would be the equation of the tangent line that I graphed up here at 3. I drew a bunch of them. It's this line. It has a y-intercept of -9 and a slope of 6. Okay? We did this last year, some of us. Now, there's also a third part to this, which is then to find the normal. Okay. The normal is going to be the line that is perpendicular to the tangent line. It goes through that point still. Here, I'll draw it on the graph so you can visualize it. It goes through this point, but it's going to be a perpendicular line to the tangent. Okay? So, do you remember what perpendicular lines, what their slopes are? Opposite reciprocal. Good. So then the slope of my perpendicular line will be -1/6, and the point is still 3, 9. And a lot of times I just let you leave it in point-slope form. So you don't have to distribute and do all that stuff. It's kind of a waste of time. So y minus 9 equals -1/6 x minus 3. Just leave it like that. What do you think so far? Should we do a hard one now?
No.
Yeah, I think so too. We're going to spend a few days on this, today and Friday. We'll review on Monday and then quiz on this stuff. There's some extra stuff coming up.
Another quiz?
Yeah. Number 4. Okay, today we're just doing parabolas. Parabolas, trying to keep it easy. There's all kinds of stuff you can do with this. You can do rational functions. You can do like higher degree polynomials. You can do radicals. There's all kinds of stuff. So here we go. F of x equals, let's do 3x squared minus 2. And we are going to, A, find the tangent slope. Find the tangent slope at x equals 1. Okay. B, we are then going to write an equation of the tangent line. And then C, write an equation of the normal line. You can leave them both in point slope. Okay? All right, let's see. Let's see. I'll let you catch up for a minute. Hopefully in the homework, let me see. So let's do it. We need to use our formula, the limit as h goes to 0. This is our tangent line formula. Limit as h goes to 0. So we're going to do f of x plus h. So what you're going to do is you're going to plug x plus h into this function. Okay? So it's 3x plus h squared minus 2. So that's f of x plus h minus f of x. Now be careful. You have to subtract all of f of x, not just the parts that you remember, but the whole thing. Okay? And then this is all over h. So get used to doing that. F of x plus h minus f of x all over h. This next part is going to be algebra coming up. It's a lot of algebra, though. If you plug 0 in right now, you'll get 0 over 0. So here we go. Can you FOIL this and then distribute the 3 at the same time? Can you? I can, but can you? Maybe? All right, let's FOIL this. We got x squared times 3 is 3x squared. My middle term here will be 2xh times 3, 6xh. My last term will be h squared times 3, 3h squared. Are you okay with that? Sure. Minus 2. Okay, don't forget that minus 2 with that. And now distribute the minus here and there. And like I said, every time with these, anything that's in the numerator that doesn't have an x or doesn't have an h is going to cancel out. It has to. So this cancels here, that cancels there. And then you want to factor. You don't want to start canceling h's here or reducing h's. You want to factor first. Okay? So you factor an h and you get 6x plus 3h over h. Yep. So that's gone, that's gone. And now, finally, people they forget to do this part too. Take the limit as h goes to 0. You get to now plug 0 in for this h. And so you get 6x. So 6x, what that is a formula to give us the slope at any point we want. And in our case, our point is, well, we don't have a point yet. We have x equals 1. So that means when I plug 1 in, I get a slope of 6. Okay, so that's part A. Part A said, what's the slope of the tangent? Slope of the tangent ends up being 6. Part B now, I need to write the tangent line equation. So in order to write an equation, I need a slope, which I just found, and I need a point, which I have half of. Now, how am I going to find the y value when x is 1? Plug it in. Don't plug it into the derivative. Oh, it's not called a derivative yet. Don't plug it into this tangent line equation. Plug it into your original function. Okay? If you want to find out what y is when x is 1, plug it into your y. Plug it in for f of x. And what do you get? 3 minus 2? Well, it's also 1. Huh. Wasn't expecting that. All right, so here we go. there's our point and our slope. So we'll go y minus 1 equals 6, x minus 1. And then to find the equation of the normal, it's such a weird thing to call it. I don't know why they call it that. I asked my professor in college when I took calculus, and he said he didn't know. So, all right, negative 1 over 6. And then he got mad at me for asking him a question he didn't know. So I didn't ask more questions after that. All right, there it is. I know. Don't be afraid of your professors in college. I kind of regret being afraid of mine.